All right, here we go. Let's go quizzes and tests first. Ready? Quiz. First quiz coming up pretty quick. It's next Thursday. I do have the date here. Next Thursday, the 14th, March 14th. Next Thursday, March 14th. And remember, we don't have school next Friday. Next up, quiz 2. Oh, boy. March 27th, and just a heads up, that's a Wednesday. Wednesday, March 27th is quiz 2, and just a heads up that the day after, that Thursday, is the day before we go on break. So I don't know what your plans are for break, but try to take that quiz 2 before you leave. All right, it's on Wednesday. We come in, we have school on Thursday, so, and nothing on Friday. And then we're going deep for the test here. Test is not until Tuesday, April 16th. How about that, huh? Tuesday, April 16th. So we're in here for a solid 5 weeks, it looks like, for this. Plus we have break, obviously, so. All right. All good with the first one coming up next Thursday, and that'll cover day 1 and day 2. All right. All right, let's start this so you have the rest of the time for yourself. Just to give you a heads up on how this unit's going to work. The first half of this unit is going to be probably things you did in Algebra 1 your freshman year. All right, it's going to be a review of that. And the reason why is I don't want to start the pre-calc topic and then while I'm doing notes be like, oh yeah, remember doing that in 9th grade? Oh, you should know it now. And just keep moving on. That's not fair to you guys. All right, it'd be a disaster, right? So I have to review a bunch of Algebra 1 concepts, and then the second half of the unit, I'll start introducing this pre-calc stuff. All right, but you got to have this down before I introduce the pre-calc stuff. All right, so what we're doing today is system of equations, solving 2 at a time. All right, you guys remember that back in your, not 3, we're not there yet. We're only going to do 2 at a time to start out with. All right, so take a look at the first example here. In a nutshell, in the word problem here, you got ship A and ship B. They have spotlights that are represented by these lines, and the lifeboat's going to be where they cross each other. Not where point A and B, but where the spotlights cross each other. So I'm looking for where these 2 intersect. All right, where are these 2 eventually? And we can't see it on the graph, obviously, but if we kept extending it, we would. But you see the 2 equations I've given you. Ship A, its spotlight is y equals 2x. And for ship B, its spotlight is y equals x plus 5. And I'm looking for where these 2 cross, aka intersect. All right, so I need an x and a y coordinate from you guys. So that's what we're doing today. All right, part of what we're doing today. All right, what's your go-to here to solve both of these at the same time? And yes, you can check on your calculator, but it's not going to be your full work. How do I solve both of these at the same time? Come on.
2x equals x plus 5.
Substitute in, Grant, yeah? You're going to do the substitution method?
Yeah.
X plus 5 equals y, so I'm going to, everywhere I see a y, I'm going to substitute it in. So I'm going to say, yes, x plus 5 equals 2x. We solve this for x, move the x over, we get x equal to 5. Again, it's not good enough though. This is a point I'm looking for where they intersect. So you're halfway done right now. So yes, x equals 5. And I'm just making sure we're all on the same page. How do you find your y value? Substitute it back in. Does it matter which one? No. All right, pick either one. Doesn't matter what I substitute it back in for. I'll take the first one. Y equals 2x. Substitute in 5. Y equals 10. All right, you can leave it like that, or if you want to be real fancy, because we're talking about a coordinate here, you can write it 5, 10 if you want, but I'll accept anything here, just as long as you have both x and y done. All right, just a little recap. We're going to get a little tougher, though. Any questions here? First one of the day, since last week, anyway. All right, here we go. This is a new type of problem maybe you're not familiar with. All right, this is not a systems of equation problem. It's what I call a break-even problem. So we got canoes here. Anybody canoe, by the way? Anybody canoers in here? No? I can canoe. Anybody?
Can you canoe?
No.
That was a joke.
I can canoe.
Yeah.
Never mind.
okay.
You're good. Stella, yeah, all right, yeah, okay. Yeah, good. Somebody fill Harper in. I don't think she's got it yet. We're good. We're good.
You got that there.
Okay. All right, let's go. All right, I'm sorry. It was awful. So here's the deal. I can do these small canoes. There's a fixed price at $18,000. So let me go over vocabulary first. Fixed cost. That's no matter how many canoes I sell. All right, I'm gonna have to fork over $18,000. All right. On top of that, it costs me $20 to do a canoe. All right, so I gotta pay the $18,000 up front, no matter how many I make or sell. All right, plus $20 for every canoe. I'm gonna sell them for $80 a piece. I want to know how many canoes do I need to sell to break even? And what does break even mean? I don't lose money making them, but on the other hand, I don't gain any money from selling them. All right, so break even, I'm going to leave it at this for you guys. The cost to make them is equal to the revenue, the money I bring in from selling them. Okay, that's what break even is. How many canoes? You help me find out how many canoes I need to make so it doesn't cost me anything, but on the other hand, I don't make any money. All right, so cost is equal to your revenue. So let's talk about cost first, so I can fill out this left side with you. The cost to make a canoe. What do you got? How much does it cost to make a canoe? $20, right? So I'm just gonna let X equal number of canoes here, because that's what I'm solving for. So it's $20, right? $20 for every canoe. So that's where the 20X comes from. But that's not your only cost. There's something else associated with it, which is what, Emma? No matter how many I make or sell, I'm still going to have to fork over $18,000. So that's all over in the cost section. $18,000 I got to pay up, plus $20 for every canoe I make. Equal to, let's talk about the revenue. How much I'm going to make. How much do I make selling them? $80 for every canoe. So there's my equal. It's not two equations. It's only one. Here's my cost. All right. Here's my cost. And there's my revenue. All right. You have to include the fixed cost in the cost side. All right. Along with how much it takes to make them. And you guys comfortable solving this? This is it, right? I'm not making a new equation. All right, here's my cost. When's it equal to my revenue? $80 a canoe. So go ahead and move the 20 over, right? How do I move that 20? Subtract it. Yep, good job. Subtract it over. So I get 18,000 equal to 60x. Divided by 60. How many canoes need to be made to break even? 300. Yep. Bless you. So real quick. I make 299. What's going to happen? I'm going to lose money. I make 301. Now I start banking that cash. Right? That's what's going to happen. All right. 300 is I don't owe any money, but then again, I don't make any. Anything above 300, I'm going to start making cash. Anything below, I'm going to start owing. I'm going to lose money. Yes, Harper.
Didn't you just start with 18,000 equals 60x from the beginning?
If that's where we ended up, yeah. So you could. Yeah, you're just skipping the first step there. That's fine. We ended up there, right? 60x equals 18,000. Yeah, that's fine.
So you don't need to show the work.
Well, at least show 60x equals 18,000. At least show that step.
Well, yeah.
But the first step, no.
But I would never I would have to show 80x minus 20x.
No.
Okay.
No, you're fine. That's fine. Okay, everyone else, we're all right? Break even? Because you'll see that again on Monday. I'm not going to go over another break even problem with you. I want to go over the two equations, two variables. All right, here we go now. And yes, I know these questions are so ridiculous. It's not real life. I get it. When am I ever going to go to the store and buy 6 toothbrushes and 5 bars of soap? I get it. I'm already telling you what X and Y are going to be here. X is going to be how much a toothbrush costs. Y is going to be how much a bar of soap costs. One customer bought 2 toothbrushes and a bar for 11, and then another customer came in and bought 6 and 5 for 38. Write it and solve a system for X and Y. All right, so we're going to set up two equations right now. One for customer number 1 and the second one for customer number 2. All right, here we go. First customer walks in, 2 toothbrushes and 1 bar of soap for $11. 2 toothbrushes. What do we call toothbrushes? X, so 2X. 2 toothbrushes plus 1Y for the 1 bar of soap equals $11. All good there. And then customer number 2 just went nuts. It must be, I don't know, big family, I don't know. 6 toothbrushes, 5 bars of soap, $38. Okay. A little bit different now than that first one where Grant was just set them equal. Right? Well, I can't do that here. I don't have y equals. So we have another method. Anybody remember the old elimination method back in the day? Can you get rid of the x's right now? Right now. Can you get rid of the x's? No, they're not the same number or different signs. What about the y's? No, can't get rid of the y's right now. All right, so you're going to have to multiply one of them by a number. What?
Couldn't you just do, take the first equation and minus 2x from each side and then get y by itself? Oh, yeah.
You could do that. Yeah. You could do that. Sometimes, though, here's my problem, though. I want to go over both methods, Harper, because say if that's a 7, that's not going to look so great because then you're going to have to divide by 7.
Obviously.
But yeah, obviously,
Well,
yes.
I don't mean it like
Yes.
that.
Yes, you can. You can move the y over and substitute it in. Yes. All right, but I know coming up that's not going to be a way. It's not going to be pretty. All right, so that's why I just want to go over this method right now. Is everyone all right if I multiply the top by -2?
Wait.
Or sorry, negative. How about I meant -5. Sorry.
Yeah.
Yes. Or I can multiply by -3.
I did -3.
Okay. Whoa.
3.
No.
I don't care.
I already did
You
that.
do you.
3.
You do you.
3.
You do you.
3.
I'm going 5.
Why?
Relax, drama queen. All right, relax. Hey, I'm serious. You do you. We're gonna come up with the same answer, hopefully. You do you. Go ahead, distribute it through. I get -10x minus 5y equals -55. Just take your time, whatever you decide to do. All right, my y's cancel. So I'm left with -4x. Oh boy, what am I left with there? 20 minus 17. No, 17.
Yeah.
-17. Probably should just look at my own notes. So x should equal, I don't care how you did it, eventually your x I'm getting should come out to be $4.25. Are we all good here? Because this is just the basics, guys. Day 1 here, just the basics. And then now, just like we did in the first problem, take your x value, substitute it into either equation. And again, please go back to one of the original ones. All right, go back and substitute it into one of the original ones. So 2 times 4.25 plus y equals 11. Is that going to be 850? So I don't care how you did it. Toothbrush is going to cost $4.25, and the bar of soap $2.50. And yes, hey, I do want to go over. You can check them. All right, remember you can check these. If you're nervous, you did them wrong, especially if the numbers get bigger. Remember how to check. You just go over to equations, type in both equations, and do your thing. Okay, so remember you can check here. You can check. All right, you ready? Got 2 more? Nice. Some Adirondack chairs here. Rocking chair and an Adirondack chair with a footstool. That's a game changer. We earned so much money by making 48 outdoor chairs. All right, how many rocking chairs did we sell? I always stick. I'm an X and Y guy. If you know, I'm an X and Y guy. So if you want to call this A for Adirondack and R for rocking chairs, that's your call. I'm always an X and Y guy. So I'm going to start off with X equals number of rocking chairs. Going against the grain here today. Blazing my own path. And Y will be Adirondack chairs. And the only reason I suggest X and Y for you guys is you guys that check on the calculator, you can't put in A and C. You got to put in X and Y. Okay, because it won't. I don't think it'll go with A. It won't show up with A and C, your answers. All right, so stick with X and Y. All right, you ready for my two equations? I can't stress this enough. Money stays with money. When you write the equation, the money stays with money. What do I mean by that? 265, 320, 13,930. They should all be in the same equation. The money stays with money. All right, how much is it for a rocking chair?
265.
265 times, for me, X. That's how much it costs. Plus 320 for an Adirondack trail with footstool. 320 times Y. Money stays with money. From that, selling those at that price, I made $13,930. All right, where's the second one come from? I still got that 48 hanging out there. 48 total chairs I made. 48 total chairs. That's got to come into play somehow in this second equation. Any thoughts from any studs here? How that 48 is going to come into play? It's not attached to any money. It's just 48 totals. Emma, what do you got?
Don't you subtract 48 times 265?
Oh, I just want one equation right now that's got the 48 involved somehow. That's all I want. What's the 48 mean? What is it?
Chairs.
It's the total number of chairs I sold. Total number of chairs. What am I calling Adirondack? Y. What am I calling rocking? X. Total amount I sold was 48. What do you got that back there, Chief? X plus Y equals the number of rocking chairs and the number of Adirondack chairs totaled up to 48. There you go. No money attached. It's just a total of 48 chairs. All right, can I subtract over X again and substitute it in? Yes, I can do it that here. I can do that here. I'm going to end up multiplying this probably by a number just to eliminate quicker, right? Anybody got suggestions that I probably won't follow?
265.
320.
Ooh, I don't want.
Negative
Okay, negative 265
Negative 320.
or negative 320. Either one, right? I can do.
Negative 320.
No, Richie? Where are you losing? Because I got to have you in here. Was it the equations or what I'm about to do? Okay, hey, I got to eliminate a variable.
So those are two different.
These are two different equations here. This is selling 48 chairs. This is making 13,930 from it. All right, now I got to eliminate a variable. Right, I got to eliminate them. All right, so I'm either going to eliminate X or Y. Right now, I can't eliminate those. They're different. I get 266X if I tried to combine them, right?
Yeah.
So I gotta make a decision. Do I eliminate X or Y? And here I can do either one.
Then you just multiply both equations.
Well, I don't need to multiply both here. I can only I should only multiply by one. Like say if I did this by negative 265, you see how the X's are going to cancel.
Yeah.
I don't need to multiply this by anything. It's gone already.
Okay.
You sure?
Yep.
Okay. Reliving the glory days here. All right, so let's distribute through. Negative 265X minus 265Y equals, that's a large number. I didn't do it this way either. I should have multiplied by 320. That's how I did it. Anybody help here? What do we get here when we multiply negative 265 times 48? Negative 720. Thank you. Okay, hey, Richie, going back to you. You see how those cancel?
Yeah.
And now I should just combine my y's. All right, and then combine what's over here. Oh boy. 5. I feel like my elementary school daughter doing this the long way. 5, that's 1, that's 5. 55, relax back there, all right? I know we had a human calculator over there. There we go. Yeah, we're good. Divide both sides by 55. How many Adirondack chairs did I sell? $22. Which is great, but it did ask me for how I should have done the 320 because it's asking me how many rocking chairs, right? So I probably should have solved for that first, but I'll get there though. Take the long route, the scenic route, but we'll get there. So go back, plug it back in. Let's be honest here. Which one you're probably going to plug it back into? The x plus y one, right? All right, so x plus 22 equals 48. So they ended up selling 26 rocking chairs. Check if you're unsure. All right. Other questions before we get to this last one? Numbers are going to get a little large here on the next one. All right, go ahead here. One bedroom condos, and it looks like 2 bedroom condos. You guys see how much the sales were? And we sold 50 of them total. How many of each unit did we sell? All right, variables real quick. Let's go x equals number of 1 bedroom. And y equals number of 2 bedroom. Money stays with money. Keep remembering that. Your money stays with money. So if we want to do the money equation first, how much was it for a 1 bedroom? Woo! 120,000. X plus 2 bedroom. Ooh, 150,000. Money stays with money. Your total amount you made from selling those. That's 7 million right there, kids, huh? 7 million. Okay, it's the first one's nice and easy. Money stays with money. Where's the second one coming in now? Think about the Adirondack chair one we just did here. Where's the second equation? X plus y equals 50. Because you sold 50 of them, 50 condos. All right, your call. I'll let you guys solve this on your own. I won't even tell you what decision I'm going to make up here. Try to solve this one on your own. Find how many of each type of bedrooms we sold. And hey, we got plenty of time here, so try checking it too when you're done. All right, make sure you're comfortable checking it. We end up with 15 one-bedroom condos and 35 two-bedroom condos. If you can't get that, we're just not circling it and moving on. Call me over if you can't get that. All right, but we should be getting 15 and 35 out.